Here's the solution to question 1 of homework 6. Look at the question 1. There are 5 problems to solve. Let's begin the first problem. We know that x is larger than minus 1, smaller than 1, and y is larger than minus 1 and smaller than 1. Because the joint density function is a very joint density function, we know that the integral of the joint density function equals to 1. So we can get this expression, and we can get a equals 1 over 4. And let's begin the second question. Is x, y uncorrelated? We can get this. We can figure out whether x, y are uncorrelated or not through the covariance of x and y. And the covariance of x and y equals to the mean of xy minus the mean of x times the mean of y. So we can get the mean of xy equals to the integral of xy times the joint density function, and we can get the results equals to 1 over 36, and the mean of x equals to the integral of x times the joint density function, and we can get the results equals to 0. And at the same way, we can figure out the mean of y equals to 0. So the covariance of x and y equals to the mean of xy minus the mean of x times the mean of y equals to 1 over 36 doesn't equal to 0. So the mean of xy doesn't equal to the mean of x times the mean of y. So x and y are not uncorrelated. Let's begin the third question. Is are x, y independent? We can figure out x, y are independent whether if we we can figure out whether x, y are independent or not through the joint density function. If they are independent, the joint density function equals to the density function of x times density function of y. So we first get the results of the density function of x. The density function of x is the integral of the joint density function, and we can get equals to 1 over 2 for x is larger than minus 1, smaller than 1. And the density function of y equals to the integral of the joint density function, and we can get equals to 1 over 2, and for y is larger than minus 1, smaller than 1. So the density function x times the density function y equals to 1 over 4 doesn't equals to the joint density function. So x and y are not independent. Let's begin the fourth question problems. Is finding the joint density function of x squared and y squared. We let z equals to x square and w equals to y square, and there are four roots. It's these four roots, and we can get the Jacobian of we can get the Jacobian through the function for the formulas, and it's like s equals to 4 times x times y. So the density function ZW equals to this equation, and we can get we can put this we can put 4 roots to the function, and we can get the final result equals to 1 over 4 times ZW, and we can get these results, and then so it means that the joint density function of x square and y square equals to 1 over 4xy. And let's begin the final problem is to prove or disprove that x square and y square are independent. We can know that if they are independent, the joint density function equals to the density function of x square times the density function of y square. So we must figure out the density function of x and x square and density function of y square. So the density function of x square equals to the integral of the joint density function. We can get this 1 over 2 times x, and at the same way the density function of y square equals to 1 over 2y, and the density function s square times the density function of y square equals to 1 over 4 times x times y equals to the density function, the joint density function. So x square and y square are independent. That's all. Thank you.